So folks, here we are once again. Welcome along now to episode 3 of our celebration that is the JCB Fastrac tractor. This is all part of our bigger series, the Icons of Agriculture, and coming up in this episode it's all about the development of the Fastrac. So going from that one idea on a single bit of paper right through the whole R&D process right through to market. Also coming up in this episode, we're going to have a little trip down the memory lane with one or two people from JCB. So it's going to be another belter. Stay tuned, grab a brew, settle down and yeah, enjoy. As if the Fastrac wasn't a fast enough tractor as it was, back in 2019 it was, right. JCB decided to set a world record for the world's fastest tractor. I'm sure many of you saw it on TV. It was widely publicised. It was one hell of a sight to see. And this chap here, Alex Skittery, you were the lead on this, were you?
I was.
Explain your role at that point.
Yeah. So I was in charge of it really. I got put on the project right at the beginning. So at first it was just me and a CAD screen and a calculator working out how do I make a Fastrac go 150 miles an hour.
So when was that bombshell dropped on you? Because obviously we saw it early 2019. So when did you get the call, Alex, you couldn't rustle this up, could you?
It was about November the year before, 2018. We did a mock-up for Christmas, so Lord Bamford's Christmas present. This is what it's going to look like. Showed that on stage.
How's that for a Christmas present?
Yeah. And he was
go,
like,
boss, check this out.
No, and he loved it and said, right, get on. I want you to go
like
150.
It, carry on.
Yeah. And then, got a few more people involved. I think there was about 5 of us on the team in total, all quite young. You know, I was the oldest and I was 26. We had a few of the old boys around JCB helping us if we got stuck and checking through things, but mostly it was
very
just
much a young team on the job.
Yeah, very much so.
And just talk us through some of the development that went into it, because there was, as we found out, as the record attempt progressed, there was 2 tractors, wasn't there? There was like the first attempt, and then there was the second attempt. So the first one was kind of the British record, second one was the world record. So talk us through some of the development work that went into this, because this isn't just a slightly faster Fastrac. There's so much work in this.
There was a lot. I mean, the remit from Lord Bamford was, you can do it, but you got to make it as Fastrac as possible, as JCB as possible. So we opened it all up on the computer and CAD, worked out what parts needed to change, what parts didn't, to make it into the machine you can see here. So probably about 60% of the bits are actually still current production Fastrac bits. Suspension.
So a good chunk of it is actual Fastrac bits.
A lot of it, and the engine as well, is JCB engine.
You didn't stick with the CSU power or AGCO power for this?
No, that was the other.
It had to be
other
powered.
remit. Had to be. Lord Bamford wanted JCB engine. Let's show off our 6-cylinder 7.2 litre.
Can we pop it?
Yeah, let's have a look.
So this is a 7.2. This is
7.2. Yeah, and actually a bit like the tractor, we had to try and keep as much of the engine as similar as possible, as current production as possible. So pretty much all the internals are stock. And we've just bolted massive turbo on. You can see a turbo back in here.
How many horse were you eventually producing with this?
Just over 1,100. We measured 1,054 going into the back axle. So there's a little bit of a loss in the transmission, but she was pumping out some power. So just talk us through some of the adaptations to get us to 1,000 horse. Well, power, you need lots of fuel and you need lots of air.
Yeah.
So lots of air, big turbocharger.
Massive.
There's an electric supercharger buried in there as well, powered by lithium-ion batteries.
Right.
And that was programmed to give us a bit of extra boost when we were changing gear.
Right, to maintain power levels.
Yeah.
Rather than having a dip. Yeah.
So a bit like an anti-lag type system.
Yeah.
And then to supplement that, we bought a scuba diving air tank, which is down the back of the machine. So you can see that around here.
So that's the easy.
so that's that one there.
Yeah.
That's got 200 bar of air in.
Right.
Regulated that down to 20 bar. This was purely to spin the turbine of the
turbine. Oh, just get the turbine going,
so
right.
Just get it spinning, get rid of all that lag. So that's plenty of air. Trouble with lots of air is it gets really warm. So that's what this big silver thing is at the front.
Massive intercooler.
Massive, but it's not an air-to-air intercooler, it's a water-to-air.
Right.
So this is a big water jacket, and we pump the air through it, and that water jacket is cooled by ice.
And that'll be what was in these front tanks from memory.
Yeah, that's right.
So if this has got the front tanks, this will be the second Fastrac.
Yeah, this is the one that went 154.
This is the world's fastest track, this one, because the first one didn't have these, did it?
No, that's right. Yeah, that's right. The first one was about 850 horsepower, slightly smaller turbo, no ice. And then when we decided we actually wanted to go a little bit quicker.
Right.
But yeah, 25 kilos of ice goes in that at the beginning of the run.
Because I remember at the big, because you did one run one way down the runway, and then you have to fill it back up again, didn't you, before you made your return run?
And there's a time period. You've got to do it all within, I think it was about 20 minutes or so.
All right. So you're on the clock, getting it turned around.
Get it turned around, get it all cooled down, and then get going again. Yeah.
And you've got these massive air scoops at the front here feeding everything.
Yeah, you've got electric supercharger, air intake. There's another one that's actually just funneling air onto the exhaust manifold to cool it down. And then, 200 degrees air goes into that charge air cooler and it comes out at about 2 degrees in less than a second.
Yeah.
And then just to cool it down a bit more, get it a bit more dense, we're squirting water in as well. So it's got water injection.
So it's really dense then?
Yeah. Really dense. We did have plans to squirt nitrous oxide into there as well, but we decided we didn't need to in the end. But
gone far enough.
If they ever let me get it back out the shed, I'd be quite keen to do that.
I'll tell you what, I'll be there. Give us a bell.
And then so lots of air. That's that side of it, and then lots of fuel as well. So you can only just about see it. But there's a big fuel pump just hanging off the back of the engine. Yeah. I think we got that off a big diesel engine off a train.
Off a train?
Yeah, 2,000 bar fuel pressure being squirted in, and then huge injectors. Yeah, absolutely massive, like 2 litres a minute, just
bucketing it in.
Absolutely bucketing fuel in.
Jesus.
Another sort of requirement of the project was we don't just want it to look like a tractor puller with big black smoke bellowing out.
Yeah.
So we did a lot of work tuning the combustion inside the cylinders, making sure that it ran clean and actually ran quite efficiently as well. There was a lot to it. We spent many hours on the dyno with this engine.
I bet it was a lot of fun as well, was it?
Yeah. Learn a lot. Learn a lot, particularly aerodynamics. We don't normally worry too much about aero.
It's not on the top of the priority list for a tractor, is it?
No.
Until you start doing 150 mile an hour.
Well, yeah, and then suddenly it becomes the biggest force slowing you down.
Because it is a big yellow brick. Effectively, isn't it?
It is. It's slightly smaller than a normal Fastrac.
It's a bit lower, isn't it?
Yeah. It's about 200 mil lower. It's all about getting that frontal area right down.
Yeah.
So it just slices.
And you've got all this at the front, just sort of steering and channeling that.
Yeah, it helps you cut through the air, but it also funnels all the air onto the cooling packs
because you want it.
They're hidden under here as well.
Yeah.
So you got water radiator under their oil cooler.
So weight must have been another challenge on this. You'd have to put it on a bit of a diet.
Yeah, normal tractor weighs, anything from 8 ton up to 9.5, depending on spec. This is about 5 ton. So, lots of work on the chassis, lightening that. We actually designed it so that it could do farming tasks. So you could put a drawbar on the back.
Hang on.
It would need a little bit of tweaking, but it's
some serious speed mowing or something like that.
it's a Fastrac axle, so you could put a drawbar on the back of there and actually pull a set of discs, and we were that close to actually doing it.
Just to show it. Just to kind of shut everyone up. It's like, see, it's a tractor.
Well, that's it, because it is a tractor, and that was the thing. It's the world's fastest tractor. It's still got to be able to do farming tasks.
That's it. And like I said, that is a JCB axle. That is it.
It is. Yeah. It's off a 3000 series. Yeah, we got that. We did a little bit of modding to it. We got rid of the reduction gears in the hubs.
Right.
So normally you've got 7-to-1 in the hubs, and we've not got any of that now. Just solid.
Straight out.
Yeah.
Did it have? I can't remember. I seem to remember. There's no diff in there either, is there?
There is a diff.
Yeah.
There is a diff, but it's welded up. So we basically just used it as a bevel box.
Yeah. Keep it straight and true as much as possible.
Pretty much, yeah, and try and give the tyres a less hard time. You can see these are worn right down.
I was going to say, because these will have taken some pain, won't they?
Yeah.
Because these had to be specially built, didn't they? Did they have some steel bands in or something?
Yeah, they've got steel banding in them, racing tread compound.
Yeah.
BKT were really good. They really helped us with developing these tyres out of a production mould. So same production line as what they normally build with.
Yeah. So looks-wise, they had this anyway.
Yeah.
And then they just added some more internal.
Like you said, some steel beading, because when we first tested them, we didn't have any steel beading, and they actually grew probably in diameter by about 50 mil, which is a bit too much.
That's quite excessive, isn't it?
Yeah. Putting the steel beading in, I think we're down to about 15 now. So at 150, they still do grow quite a lot.
That's it.
Yeah.
And did you ever get a chance to drive it or not?
I did, yeah. After the record, I went
get the record.
Get the record in. Went 98 miles an hour in it, and then basically just bottled it, and I was like, I need to slow down now.
What did he feel like?
Really smooth. It's a Fastrac. We designed them normally to go quick on the road, quick in the field, and we reused all the suspension geometry, all the steering geometry, and on the runway, you wouldn't know you're going that quick.
Because I remember it sort of looking really planted, really stable.
Yeah.
There was no twitching at any point, there was no drama, it was just...
No, and that's what Guy said when he was going 150.
With work boots on, that's just...
Yeah, with his JCB dealer boots on. And he said it just felt smooth. Yeah.
Walk in the park, really.
Well, if we had a longer runway, I think, we could have gone quicker.
Well, that was one question I wanted to sort of bring up at the time was, because your top speed was 150 something or other.
154,
yeah. But your average was, what was that?
135.
135. Yeah. So if you'd have had a longer run up to that timed gate area, could you have maintained 150 for longer? Could have this been... Yeah.
It was all designed. I mean, you can see that the cooling pack, for example, we had to put metal plates in because it wasn't getting warm enough when we were driving.
Oh, right, there was that much air going into it.
There was that much air. We only got into fifth gear. We've got 6 gears.
That's proper like IndyCar spec, Formula 1 spec, where they start closing these off as the machine starts going faster because there's that much air being forced in.
More for
well, you did have Williams helping, didn't you?
We did, yeah. Williams helped with the aerodynamics on it quite a lot. Yeah, we learned a lot from them doing it.
Well, Alex, thank you very much for your time. It's been a great little trip down memory lane, just taking us back to this. And one day, if you get a slightly bigger seat, we'll have to have a bash. One day.
We'll give you a call.
There you go. Yeah. Don't call us, we'll call you. All right, thanks, Alex. Nice one. There we go. Spot on.
Rightio, thank you.
Right, folks, my next guest has, well, you've pretty much been around the world with the Fastrac. This is Mr. John Smith. He is the Managing Director of JCB Agriculture. That's what he does now. But, John, just share your memories with the Fastrac, because like I say, you've literally been around the world with this and seen all the markets that it went into. So, what are your memories of that?
Yeah, well, thanks, James. Oh, it's great. It's a great lineup. It's a lovely day to be out in the fresh air.
It's a heck of a lineup, isn't it?
It is.
Like we were saying before, you just forget that 34 years heritage there from start to end.
Yeah, it's brilliant. It's brilliant to see. And I've been around my career at JCB spans 25 years. I've been around a fair bit of these models and seen the introductions and the launches. And
so, what is some of the ones that you sort of worked with / worked on, brought to market? What were the ones, your early ones that you were involved with?
Yeah, so 3185, which you see here.
It's that honey.
It's a lovely model, well received around the world. It's a real workhorse, loads of power to the ground. And that 3000 series really built a strong reputation in a part of the world where I spent a lot of time promoting Fastrac, and that's in Australia. So,
would you say that 3000 series, that really put the Fastrac on the map?
Yeah, it did. Yeah, I'd say so. Especially that horsepower at that time was just what the market needed. And I'd refer back to Australia. I ran our Australian business for a number of years, and the Fastrac was just in its infancy really down there, and it just took off. And that 3185 was the key.
It was down to that.
Yeah.
Right. So you looked after Australia for quite a while, did you?
Yeah. I covered that market for a while for JCB, grew the ag business, and the farming down there really, the attributes of Fastrac really fitted in well.
Yeah.
It's broad acre farming, so
long distances, I would imagine.
Long distances, big fields, fields that are 20 kilometres long, and I know that's. Yeah. And those guys, when it rains, they need to preserve that moisture for their wheat crop as much as possible, and they don't want the weeds taking all the moisture, so they tend to spray, and high-speed spraying was the thing. So 3185s, and then the 8000 series that came, pulling trail sprayers.
This newer one down here, if you have a look at that.
8250 series one, so a bit of a revolution at the time. It was the biggest tractor that we'd brought to market, 250 horsepower. So this was a model that I was heavily involved with, and of course it came with a CVT transmission, which at the time was really cutting edge.
Yeah. How well was that received on with your Fastrac customers or potential new customers?
Yeah, they just loved the fact that the transmission was push and go really.
Yeah, just point and shoot.
Yeah. They didn't need the complexity. A lot of these machines were driven by backpackers.
Really?
So the simplicity of the machine really found its. They needed to cover large ground. They were pulling chaser bins, they were pulling boom sprayers, balers occasionally, but mainly in that wheat growing areas. Keep it simple,
possible.
Yeah.
And this just answered that.
Absolutely. And it's always been a hallmark of the tractor is to try and make it as easy to use and as simple to use as possible, whilst giving loads of benefits to the customer.
So you were heavily involved in the Australian market. Were there any other markets that you worked in as well?
Yeah,
took the Fastrac around the world.
Yeah, I suppose when we launched the 4000 series, I was back in Europe at that time. All my fun and pleasure down under had finished, and I was back in Europe.
You'd done your stint down there.
I'd done my stint down there,
How long were you down there?
I was there for 9 years.
Right, you'd done a proper stint then?
So I did a proper stint, Right. So, and then when I came back to Europe, we were just about to launch the 4000 series. And of course, it took Fastrac onto a new level, really, in terms of cab comfort.
This was a big leap, wasn't it?
Yeah, it was a big leap forward,
I
wasn't
remember,
it?
It's... From what we'd seen before, 90s, late 90s, then this comes along, it's like, oh, hello.
And we were replacing the 2000 series, really, the 2140, 2170, with this model range, and we needed to modernise the cabin, clearly, the transmission, and the attributes of the machine in terms of hydraulic flow and
just everything,
power and everything. Yeah. 2000 series really well received in UK and other European markets, but 4000 series changed the face of the Fastrac business really as a consequence of the spec and the performance and the reception of it.
That's it. That's it's kind of sort of what the 3185 did for you.
Yes.
This sort of did it again. Would that be fair to say?
Yeah, absolutely. Yeah, it was a major milestone for us. Modernise, the cab room, the comfort, and then of course, latterly when we developed the Icon cab and all the integrated technology as well, that took it on one more level. So it's great to see a lineup like this, and you can plot your career by it all, can't you? I can think where I was when we launched that, what I did then, and Do you know what sticks with me in that Australia and New Zealand piece was the customers I met, the use, the fact that we were so far away from this part of Staffordshire where it was all where the heritage of the Fastrac lies, and you were meeting customers who were so passionate about the brand. And wherever you go around the world, we're a relatively small tractor player, aren't we, in comparison to John Deere or some other brands. But you met these customers, and the loyalty to the product and the performance that the product gave them, and it was like it's a fan club, and the people who have gone in this role that I'm doing, and people around the Fastrac, I know them all personally because we're all part of that same club.
It is a people story, and it's built on people, isn't it? Which absolutely. We're gonna, I was talking to a lot of them in this, this mini series celebrating, the icon that is the Fastrac. So some of the stories that we've heard already have been fantastic. So we're looking forward to hearing more. But for now, John, thank you very much for your time, for taking time out. I know you wanted to come out and play anyway, so. But thank you very much for coming out. It's been awesome, that. Still loads more to come. Right folks, now time for a bit of development chat of how they actually develop these tractors and eventually bring them to market. As you can see, once again, we've got Robin Carter with us, and we're going to get another one of your colleagues a bit later on as well and get a bit more in-depth detail about the development process. But for now, Robin, kick us off. Where does it all start? When you have these grand plans, these big ideas for new tractors, where does it all start?
Well, ultimately it starts with a project letter, just a one-pager with a bit of a business case for the new machine. What might the market be? What does the customer want? And often in the past, if we think back over the last 20 years, much of tractor technology, many of the tractor launches that have happened have been around emissions. Of course, with every emissions, the customer's expectations changing, farming's changing, tractor size is changing.
Technology's increasing.
Yeah. So everybody expects with those product launches us to put more in the package at the same time.
And get more value for money as well at the same time.
Yeah.
So, like for example, we're driving a Fastrac 4220 today. When would sort of like development of this start? Because it was launched, what was it, 2013, 14, somewhere around there?
Yeah, we launched this in 15.
This was 15, right.
That's right, yeah, so I led this programme. This was nearly a 5-year development for this tractor. So we start with the driveline, the big lumps, the engine, the gearbox, where do we want the axles, what should the wheelbase be? We try and get those in. Everybody's grabbing space claims in CAD, called them space claims. So they're grabbing their real estate of where they want their cooling pack, or where somebody else wants his hydraulic
pumps. You don't really think of it like that, because it is a fight like for space, isn't it? The engine engineers, well, we want this perfect position. Gearbox engineers, well, no, we want it there.
Yeah. Actually, I suppose winding back a step, the first thing we do is we try and visualise what the tractor might look like. Yeah. So we try and set that vision and ask the customer, is that what you want out of that product?
Yeah.
So we start with that silhouette line. I remember with this, we drew the silhouette of the bonnet of the cab, and we asked the customers, is that what you'd like? We made one. We made plastic tractors, full-size plastic tractors. Yeah. We put them in a lineup around everybody else, and you can get in and look and feel the tractor. I remember with this 4000 series, a lot of discussion around the 4-cylinder engine. At the time, would we want a 200 horsepower 4-cylinder? Would we go up to a 6-cylinder? And still see that fight in the marketplace today, don't we? With that charge going up towards 200 horsepower. On
that good old argument of 4 versus 6, isn't it? Yeah. I suppose at the time when this was being developed, the 4000, the perception would be actually no. We still want a lot of customers still want a 6-potter at that stage.
Yeah. So once we draw that silhouette, really, that's what I'm sticking to. I mean, not quite as particular as the car guys, where that silhouette line can't change. But we're arguing over whether something's sticking through the bonnet or not. Because once we set that vision of where we want our visibility line to be, the seat that can turn nearly 90 degrees sideways in the cab, everybody's got to be able to package around that. So we define those space claims, and then everybody's got to start getting their parts inside it. We go through that concepting phase. We build our first test and development tractors.
Yeah.
So that first generation of tractors we put out, mule tractors, perhaps tractors that are converted from previous generations of tractor.
Yeah, a bit of a 3000 in there with something different on it.
A bit of a hodgepodge of tractor, that's right. But you put that together, and that's your first chance to drive that machine and see, are all these systems singing, is that what the customer wants? You can't lose sight of that. You've got to check, is that definitely the product that we want? Yeah. And when it is, and we go through that stage of the gate, our first sort of major milestone in the gate is around customer acceptance, that we're designing the right product. We look for our bill of materials, and we've got all the right parts in there. We've engaged the right suppliers, and then really it's a 18-month design phase.
Yeah, getting nailed down.
Getting that nailed down, and getting a tractor that we can then design. We can build the parts to, and we can get up to a validation, a test endurance level tractor. So we think about tractor development, we might go 3 or 4 generations of tractor through the first concept, the test and development machines, the ones that we're going out and doing the pre-testing with, then into our validation, our endurance phase of tractor, and then any mop-up changes, minor changes that people might want, or the design for manufacture part, we're putting them through the factory, we're realising there's tooling access issues or something like that.
Well, that's it, you've got so much things to think about. It's not all about designing the perfect tractor, but actually, how do you maintain the tractor? How do you build the tractor? Is this going to work in our production line? All those processes you've got to think of.
Something like the touchscreen, we rapid prototype the software on iPads. So you can go to customer clinics and you can show them how they would swipe and go through the screens. And
so you can do that virtually, basically?
Virtually, before we ever start coding anything, we'll be rapid prototyping that software. It's on iPads, you can start swiping through and coding it. Same with software coding. The guys will be rapid prototyping the software, and they can quite quickly plug in on banana plugs into the ECU, they can connect with hydraulic valves, they can tune the software, develop the software, get it how they want to be. Then we'll hard code the software and it goes into the actual ECUs in the tractor, and then it's a whole nother validation again. Something like this armrest we see here, we tried our best to make everything really obvious and easy to use. That's the great thing about having tractor guys working in software. Tom, who developed that code, it's absolutely understanding how he drives the tractor and how customers are using it, and you and I get in it too as tractor guys, and it feels really intuitive to use, doesn't it?
So today, right now we've just been cruising around this test track of yours. Tell us about this track, this facility where we're at.
Well, this is one of the JCB test sites, and historically we'd have done thousands of hours of endurance on this kind of test track. There might be tether tracks, which are big steel cables attached to the machine, and it would go round and round in circles over different surfaces. Or here we've got all the different bump tracks and rumble strips, and we do thousands of laps of these.
So this one says quarry floor, but to me that just resembles roads in the northwest of England. It's literally just potholes, isn't it?
Go on, chuck her in cruise control and give us some steer.
Oh, let's have a back. Foot to the deck. It's like a magic carpet ride up here, isn't it? So this one, what do you call this one here?
This is the wave motion.
This is wave motion.
So this is where you can get everything out of sync, particularly if you've got a big plough on the back and a weight. You get out onto the fens or onto the marshland, you get a lot of sunk roads.
Of course,
You can get everything nodding, and you have to be quite careful on this. So we want the ride and handling of the tractor to be good. We don't want the suspension underdamped or overdamped.
No, you don't want it throwing it the other way, do you?
No. So particularly when you've got ploughs on the back in this kind of low condition, when you get a nod on the tractor, it's a really good one there to tune the suspension.
You get into that horrible frequency, don't you? And it's just,
it's a really good one to tune the suspension on.
What we got here? Regular curbs.
So here we're going to drop off curbs, stepped inputs.
Can you imagine that with a regular tractor?
Just watch the suspension moving. And you forget, you're sitting here and you just look at the front axle. You've got to remember, you've got rear axle suspension. That is the big deal. Watch how that rear axle's moving.
Look at that. That suspension works hard, doesn't it? That's doing so much work. Well, that's the underpinnings. That's
you can feel it. The only way you can see that, you can feel it in the heat and the hydraulics. In those accumulators.
Oh, so if I put my hand on them now,
she's running
after they've had a workout.
Right.
But this is the DNA of the Fastrac.
That's right.
Ride
and handling and suspension. That is absolutely. That's the core functionality of the tractor.
This is what I'm looking forward to. What we're calling this one here. Hellish rough is what this is called.
Let's knock her into stick. Come on.
Right.
I'm gonna take the speed here.
There we go.
Look at this. This is where you break fenders. Look at the workout that fender's getting.
Can you imagine this on any? Well, no other tractor can do this.
This is what we call, of course, a regular curb. Everything's out of phase and everything's wobbling around.
Oh! But from where we're sat, this cab stayed level. You're sat in the passenger seat. You've not moved. The cab's level, and the suspension is just doing everything. Isn't it? Doing all the work.
So what we'll do is we'll record this data. History tells us what we've got to do for the life of a tractor. The holy grail in your design engineering is what the duty cycle of the tractor is. How many thousand laps do we need to be able to pass on this to last for the lifetime of the tractor? And that's our intellectual property. That's what sets us different to a competition tractor. So we've all got our expectation of what life looks like. The real secret within the engineering is understanding what the life expectancy would be in all these different conditions. So going down the regular curb, the random curb, we've built up through history what our expectation should be and how many hours or how many thousand laps we should be doing of this. And then we'll record this data, and this is what we now can just play back through the 4-post rigs. We can excite the tractor, we can just replay all the most damaging part. So we haven't got to record this bit where you're driving around the end, we'll just record this bit. This is a random curb, and I mean, just knock that stick forward.
It's unreal, isn't it, really?
You take for granted how good it is until you get in a different tractor. Until you get in a standard tractor, you take for granted how good this is.
And well, that's it. I mean, we're not knocking other tractors. There's some fantastic suspension systems on the market, and some of them do an amazing job. Some of them, they're comfy, but you lose touch with the front end. They get all wafty and wavy and horrible.
You've got quite direct feedback, haven't you? The reactive steering feeds back into the steering wheel.
Exactly. It feels planted, is the word. You know, you don't.
There's always a design trade-off, isn't there? I mean, the trade-off is the cab, to feel good, the cab's in the middle of the tractor. People say, well, my visibility to my pickup hitch.
Yeah.
All right,
but you're at the pendulum point, aren't you?
That's right.
So the rest of the tractor
cab's pivoting about your ears.
Rocking. That's it.
Yeah.
Cool, right, Robin, shall we hand over to Rich?
Rich tell you all about the validation phase on the tractor. This is Rich's job now. So we've been through the concept phase, we've checked with customers what they want, we've gone through that design evolution, we've tested the core functionality, and then we're out onto validation, and Rich and his guys now, they're making sure the product's ready for the customer.
Right, folks, so we've swapped over passengers, as you might be able to tell. So we've dropped Robin off, and now we've got Rich Cadman here, who is going to sort of carry on the development chat, more about sort of the validation side of things, isn't it?
Yeah, the validation and the more practical elements of it. The fun bit, really.
The fun bit for you. Yeah, go on. So we were talking about, particularly with this 4000, when it was originally launched back in 2014, 15, somewhere around there.
Yeah.
And we were talking about the period before that. Talk us through those, that validation period before it actually does go to market. What happens?
Oh, well, yeah. There's just so much to talk about, I guess, and it's quite a long time. It's quite a long time ago now, isn't it? We're going back.
It is actually
10 years to launch, and I guess we were in the thick of the hands-on development in probably about 2013. Of course, at that stage, it's all about just proving the concept. You know, does the suspension work? Does the steering work? Is the ride and handling acceptable? Is it doing what
it should be doing?
What it should be doing? Is it delivering the performance that the marketing guys have asked of us and asked from the
promised.
tractor? Promised, yeah. So that, there's a lot going on, and in those early sort of months of getting the first prototype, I mean, it really is exciting because everybody's dead keen to.
It's brand new, isn't it?
Brand new. Get out on the first tractor.
So what element would you start testing first? What could, like in your sort of checklist of sort of tests? What do you start?
Well, it really sort of starts with the drive line. So the big bits of hardware, the expensive bits.
Yeah, the engine, transmission.
So it's engine and transmission, and it, on the 4000 series, really, it was about the transmission because that was the real big bit, the big step change, if you like.
Yeah.
So it was all about getting the transmission to perform. Now, when we built the first machines, ahead of the transmission and the driveline actually ended up in the tractor, we did quite a lot of rig testing with the suppliers. So there was a lot of high hour rig testing done on the Fendt transmission before we got it in the first machine. So we already had some good confidence that it was going to do what we wanted it to do. So that drove out quite a lot of problems in the early days.
Right.
Problems with lubrication.
So you do quite a lot of fine tuning at that point.
Oh yeah. Even before you get to putting it in the tractor, you've got to be, confident that it's hitting the mark pretty close.
Yeah.
But it's more refinement really. It's the difference of is something going to last 500 hours or is it going to last 5,000 hours? It's small refinements in maybe lubrication or.
And it's only just a matter of a tweak, isn't it?
It really is, and there's some really fine tolerances in these CVT transmissions.
Yeah.
So you really are in a real level of detail to get the ultimate performance out of it. But
and then what would sort of come after engine transmission? What do you move on to then?
So we're then probably into suspension, you know, because that's like it's a key attribute of Fastrac, isn't it? It's what makes a Fastrac.
It is, it's kind of
the Fastrac
DNA that
yeah,
I've said all along.
Absolutely,
really.
It's probably been said before, but it's part of what Fastrac really is. So it really is that one of the key systems that we really do have to pay a lot of attention to. And
yeah. You can't drop the ball on that one, can you?
Not really. And it, you know, I think just driving this round here today, I'm not even thinking about how fast we're going. We're driving around here.
We're just on
25, 30, 40 miles an hour, aren't we? And
a big yellow magic carpet. That's what it feels like.
It is.
Sat up here, because like when we were going over those rough tracks before, the cab sits still, and the suspension, you know, it's doing its work.
Yeah. So yeah, suspension, massive development exercise, you know, and it's about developing the suspension cylinders, the suspension dampers, and then pretty key but can be overlooked is all the hoses and pipeworks that are connecting the cylinders to the valves, the dampers, the accumulators, you know, refining that to give us this pretty superb ride is, you know.
So get that one ticked off. What's up next on your validation
it's then got to be brakes, really.
Stopping power,
because it's another Fastrac.
Yeah.
You know, sort of Fastrac unique selling point, DNA, isn't it? Big brakes, good stopping power.
That's it. Big outboard disc brakes, one on each corner.
One on each corner. Everybody likes the look of that. You know what you're getting. Yeah. But it's, you know, it's the ABS element to that that's quite special as well. And we've had ABS on Fastrac for many years now. You know, there's loads and loads of real technical stuff that we do with brakes, but something that always comes to mind with me, and I think anybody that gets involved with it thoroughly enjoys, is when you get onto the validation of brake system, where we take the tractor over to Sweden for winter testing, and when we're over there, we're validating the performance of the brake system on ice, so on the frozen lakes. Yeah. So that really is quite exciting, because
I bet it is.
You know, when you go, you know, for 60k over polished ice, and the tractor will pull up absolutely dead square is a pretty special thing to experience. But some of the other tests that we might do over there is where we'll run the tractor down a really special track where the left side of the track is heated, so heated tarmac, so you've got loads and loads of grip. Right. But the right hand side is polished ice, and so you basically drive along this on the tractor, and then you apply the brakes, and when you've got it right, again, the tractor will pull up absolutely dead square.
Straight and true.
Yeah, straight and true. Yeah, absolutely. And if it doesn't, then you sort of puts you into a spin, which is quite interesting, I should say.
Yeah, grabbing all the full handful of opposite lock on this.
Yeah, absolutely. Yeah. So that's some real interesting testing that we do on brakes. But also, while we're, you know, in a cold climate, then we'll look at other aspects of the tractor performance. Does it start in the cold, -20, -25, well, even -30 in Sweden, Scandinavia? You know, they're not temperatures that we see in the UK, but of course for those customers in that part of the world, it's just normal life.
Perfectly normal, and they expect the machines to work in that as well.
We go and turn the key on a sunny June day in Blighty, but in Sweden or Finland, you know, they'll get up and it'll be -25, and they expect the tractor to start. Yeah. So, and, you know, it's about, has it got the right diesel? It may need a block heater in the transmission, a block heater in the engine, and it's about how the hydraulics and the fuel system perform when in those low temperatures, you know, when the viscosity of the oil is really thick. Yeah. And it's something that we don't see over here, but
that's it. And conversely to that as well, you're going to have your hot climates as well, aren't you?
Absolutely.
You've got to think about their needs.
Absolutely. We try and do, you know, the extremes of temperature, so we're covering, you know, most of the applications that customers worldwide are going to see. So when we're talking about hot testing, for example, now we're going to the topic, then, you know, we'll take tractors to Spain in the summer, So we will, we'll be putting in temperatures 35 to 45 degrees.
It's got to be proper interesting testing tractors, hasn't it?
It really is interesting.
It's not. It can't be a bad job, that.
No, and you sort of think, I love tractors, probably like you. When you come from a farming background and you're sort of brought up with agriculture,
this is the ultimate, isn't it?
And you come to work every day and you're working on tractors. It is. I know it sounds a bit cheesy, but it is really good. It is really good. And then you look at what you've actually, this is what we've done,
And it goes out into the market, and you start seeing them around the world as well.
Yeah, it gives you a pretty good feeling.
It's good, isn't it?
Yeah. So I mean,
that's your major stuff. Then.
That's the major stuff.
What you're sort of finishing with then, validation wise.
Yeah, I mean, once we've got the big stuff out the way, and we know the tractor's gonna mechanically perform, we're then moving on to software development, which in more recent years has become a really big part of the job. We're looking at the touchscreen, aren't we?
So all this increased technology.
We basically run through tens of thousands of individual tests to make sure the functions work correctly. But then also, if you get a fault code or a problem, that the tractor behaves in the right manner, and it will go into some sort of safe state. And then of course, once we've got the software in a usable state, then we start to place machines out with real customers for for effectively 4 seasons of tractor development. So to sign a tractor off, we want to make sure it will work in the winter, the spring, the summer and the autumn, and all those different seasons bring different challenges. So
that's it, because like the duty cycle of a tractor, it's not like evaluating a truck, which I mean in a lot of cases it's got one job, hasn't it?
Yes,
drag stuff around.
Yeah, it's a really good point.
The tractor duty cycle and all the jobs and applications it does, it's almost endless, isn't it?
It is. You're absolutely right. Like you say, with a truck, it's either grossing at 44 tonne or it's empty, isn't it? There's not a lot in between. But with a tractor, one day you've got your triaxle silage trailer behind it, but then another customer somewhere else in the world could be doing something weird and wonderful, like having a deck mounted mower on it and a front mounted verge mower, or some equipment for cleaning solar panels, and then we've got the difference between ag spec tractors and utility spec tractors. I mean, the sort of duty cycle and the use cases are really, really, really endless. So we find it really important to get tractors out in as many applications as we can in that development period.
And then, coming towards the end of the validation phase, you've got them last couple of months to go before it gets the big reveal.
Yeah, pretty frantic.
What are we talking at that point? Is it just final tweaks at that stage?
It really is refinement, and it's not till the end really that everything really starts coming together. And it really snowballs at the end, where you start to go from a machine feeling prototype to it really feeling production ready. And in those, in the months where we place tractors with customers, they're running with data loggers on there, so they're logging everything that's going on all the systems on the tractor, the CAN network. We can then access that data remotely and download it. So if our customer rings up and says, I've had a problem with the rear hitch, it stopped working, what's going on? We can download it, we can interrogate that data, and then, most cases we can have a fix in place in the next few days, or even in the next few hours.
Get that one solved, get
that one solved,
ready,
get rid of that problem, move on to the next. But there
we go. And then it's out to the big wide world then.
Out to the big wide world.
And then presumably you start all over again.
Yeah, that's pretty much how it goes.
Much it. Well, Rich, it's been an absolute pleasure. Thank you very much for sharing that, that proper insight into what you guys get up to.
I hope some of that was interesting. I mean, we could just keep talking for hours and hours.
I love development chat and R&D chat, and but I'm getting slightly dizzy driving around this test track. We've put a few miles in while we've been here, haven't we?
Yeah, we have. I mean, I've
got
lost
a bit
count.
of data off this. So.
Yeah, probably, yeah.
Yeah, no, it's been absolutely spot on. So, yeah, thank you to yourself, Rich, and yeah, thanks to Robert again. He's over there. That's been, yeah, it's been absolutely cracking. Thank you very much.
You're very welcome.
So there you go, folks. That brings us to the end of episode 3. I hope you've enjoyed it as much as we have. And if you haven't done so already, please do go check out episode 1, which is all about the history and evolution of the Fastrac. We've also got episode 2 out there as well, which is all about the production of this tractor. And depending on when you're watching this, we've also got episode 4 coming up, where we'll be out in the field with a long-standing customer of the Fastrac. So like I've been saying all along, get stuck in and enjoy.